Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. And there's a lot of really smart people there. Today's puzzle is called Region Thermo 4 by Red Barchetta. And here are the rules. I'm assuming normal Sudoku because this is a sort of Sudoku puzzle. So normal Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have region sum lines, where box borders divide blue lines into sections with equal sums. Blue lines and their section sums may be different or maybe the same as or different from other blue lines and their section segments. In their section sums. I can't speak. I don't know why. Anyways, as an example, this digit must equal the sum of these three digits. So you could have something like, say, 9, 6, 2, and 1 here. And this would be valid because the digits along on this section here must equal the sum of the digits along this section here, because the box borders divides the line into sections with equal sums. And 1, 2, 6 adds up to 9, and 9 adds up to 9. So that's an example of how region sum lines work. And we have slow thermometers, where digits may not decrease as they move along the thermo from the bulb end. So that's the reason why I placed this in this order, because we have 1, which is less than 2, which is less than 6, which is less than 9. But we could have something along the lines of, say, like 3, 3, 4, 7, 8, 9. That would be valid because this does not decrease on this section here. What you could not have, though, is something like, say, 3 and then 2 here, because it's decreasing from the bulb 3 to the 2 here, which is not allowed on any of these thermometers. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. What I like doing for long thermometers is basically going from the bulb to the tip, looking, especially these are long thermometers. What I like doing is going from the bulb to the tip, looking at what each minimum digit is possible, and then going back from the tip to the bulb, looking at the maximum digit, and then filling out the cells for what the minimum maximum for each cell is. So this can be 1, obviously, because it's the smallest digit possible. These could also be 1 because you just have to not decrease on these slow thermometers. This digit has to be 2, though, because it must be greater than this. This digit must be greater than 2 because it's in the same row as that digit. So this is 3. This is it. This could be 3 also because it's in a different box. But this has to be 4 at least. This must be at least 5. This must be at least 6. This has to be at least 6 because it cannot go down. This is 7. This could be 8. So this is at most, let's go from here, 9. This has to be less than that, so it's 8, less than that, 7. This could be the same as that, 7, 6, 5, 4, 3, 2. So this is 1 or 2 here, 3 or 4 here. This could be 3, 3 to here. This is greater than that, 4 greater than that, 5 greater than that, 6. But we know the sum of these 4 digits must equal the sum of these 3. And these 3 are at least 6, 7, and 8. This is 1 here at least, 2, 3, 4, 5, 6. So these are all greater. 6 means this could be 6 here. 7 and 8, so this is 9 here. 8 here, 7 here. This could be 7 because it could be the same digit. This could be 6, 5, 4, 3, and 2. So this can't be 6, because if this is 6, that would be 5, 4, 3 guaranteed here. And that only adds up to 18, I believe. Yes, 3 and 6 plus 4 and 5 is 18, whereas this definitely adds up to at least 21. So this cannot be 6 here. It has to be at least 7. And that doesn't restrict anything there. This could be 9. We could have 8 here. But the problem with this being 8 is that you have 8 and 9 here. That means this is at minimum 3 and 4. That's 7 plus 8 plus 9 is 24. And that would work for this, adding up to 24. But then this would have to be 7. That would be 8, and this would be 9. So this cannot be 8 here. It's 7 at most here. This is 6 at most. This is 5 at most. So this could be 3, 4, 5, 4, 5, 6, and 5, 6, 7 there. This is 1 at minimum. You could go 2. This has to be at least 2, at least 3, at least 4. This cannot be 5 because of the same problem here. Actually, this can't even be 4. 4 plus 9 at most plus 3, 2, and 1 only adds up to 19, and we know the sum has to be at least 21 because of 6, 7, 8, and 1, 2, 3, 4, 5, 6 here. So this cannot be 4. Can it be 5? No. If it's 5 there, 5, 1, 2, 3 adds up to 11, plus 9 is only 20. So this has to be at least 6, which makes this at least 7. So we have 9 here. This must be less than that, 8. This must be less than that, but it cannot be 7. If it's 7, you have 7, 8, and 9 already here. That adds up to 24, and the most these 3 digits can be is 24. You can't have 6 here either. 9 and 8, 17. That kind of works. Can't be 7 here. Can't be 6. That's 23 plus at least 3. Can't be 5. So this has to be 3 or 4 here. Right? So 9. That's not true. It doesn't have to have an 8 here. Cannot be 7. Because 7, 8, and 9 already added the 24, and then plus 2 other digits, it's not going to be, it's going to be greater than 24, which is the most this set of 3 digits can be. If we have 6 here, this could be 7 and 8, which does work. So this could be 7. So this is 3 through 7 here. This, you could sorry, you can't have 7 here. It's 6. So it's 6, you could have 7 and 8 here. And then 1 and 2, which adds up to 24 at minimum, which is the maximum this could add up to, so that does work. So then this has to be 3 through 6. This is less than that. If we have 5 here, that would make this 6, 7, 8 at minimum, which is already too big. 5, 6, 7, 8 adds up to 26. 4 does work because we could have 5, 6, 7. So 4, 5, 6, 7 adds up to 22 plus 1 could add up to 24. So this is 4, 2, 3, 4. This is less than that, 1, 2, 3. Well, we have a 3, 4, 5, 6 quadruplet in row 5, which eliminates 3, 4, 5, 6 in the rest of the row. So this can't be 3, 4, 5, 6. It's 7, which forces this to be 9 here. That eliminates 7 from being here. And this can't be 3 because of the 3, 4, 5, 6 triplet in the row. Or quadruplet. Which means we have 1, 2, 8, and 9 left in the rest of the row. 7 eliminates 7 here. That makes this hold up, that doesn't work. This is 8 then. And that forces this to be 9. So that's not going to work. How did we mess this up? Huh. Um... Oh, one thing is this can't be 2, because if this were 2, that would guarantee this is 1, and that would eliminate all possibilities for that cell there. So no 2, which means this can't be 3. Uh... How did I mess this up? Because that forces this to be... Oh, this could be 8. I don't know how I eliminated 8 from there. Okay, yeah, that's a thing. So we have a 4, 5, 6 triplet, which eliminates 4, 5, 6 in row 5. Which eliminates... that means 4, 5, 6 cannot appear in the row 5. So this can't be 4, 5, or 6. This can't be 4, 5, or 6, so that makes this 3, which makes that 7. 7 eliminates 7 there, so it's 8, which makes this 9. 7 and means this can't be 7 there. It has to be greater than because they are in the same box and can't be 9, so that's 8. So we have 3 and 7 here. This can't be 3 because of 3 in the row. No 7 here because of 7 in the row. This can't be 8 or 9, which means this has to be 1 or 2. So we have a 1, 2 pair in row 5, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2. It's 8 or 9. 3 means this can't be greater than it, so this must be 3 here, which makes this 2, which makes that 1. But we have 8 and 9 here, so this sum adds up to either 23 or 24. So this sum must add up to 23 or 24. If this were 6, that would force us to be 6, 5, 4, 3, 2, 1, which is only adding up to 21, and that's not the same sum as this. So this must be 7 here. That makes that 7 there. That 4, this adds up to, this must be 7, 8, and 9 to add up to 24. That means, well, we don't know about this. Well, it can't be 6, because if this is 6, you have 5, 4, 3, 2, 1 guaranteed here, which only adds up to 21. So this is 7. These add, so 3, 7, and 8 add up to 18, plus 6 adds up to 24, so this is 6. Can we have 4 and 5 here? I think the answer is no. 1, 2, 3, 4, 5 is 15 plus 7 is 22. So this can't be 5, it's 6. And I think that makes this 5, right? 1, 2, 3, and 7 is 10. 2, 6, and 1 is 9. 19. 24 minus 19 is 5. So that's 5. Makes that a 4. This is 3. 8 eliminates 8 from being here. Okay. So we have 7 here, which means the remaining 3 digits must add up to what? 24 minus 7 is 17. So you could have 179, 269, or 278 here. 4 eliminates 4 here. So this is 5, which makes that 6. 5, 6, and 7 is 18. 24 minus 18 is 6, which has to then be 3, 2, and 1. So that's 3, 2, and 1, which eliminates 1 here, so that's 2, which eliminates 2 here, so that's 1. So this is 9. 24 minus 9 is 15, so it could be 6, 9, or 7, 8 there. Okay. The sum of these 3 digits must equal that digit here. We could have 1, 2, but this can't even be 2. So it could be 1, 3, because you can't have 2, 5 here. This is 4, 8, and 9 here. 8 can't be here because of 8 in the column. So we could have 1, 3, and 5 here at most, adding up to 9. This is a sum of 3 unique digits. It can't be 6 or 7, so it has to be 8 or 9 there. It's so this has to add up. If it adds up to 9, it's 1. It could be 1, 3, 5. It could be 2, 3, 4. It cannot be 1, 2, 6 here because we can't have a 2 here because of 2 in the column. If it adds up to 8, it cannot be 1, 2. It has to be 1, 3, and 4. So this is 4 or 5 no matter what, and this is guaranteed to be a 3. Okay. Let's go for here. Remaining digits in... So this cannot be 1 here. This is at minimum 2. So minimum 2, minimum 3, 4, 5. This could still be a 5 here. And this has to be greater than that digit, so it's at least a 6. You could have 9 here, 8 here. This could still be 8, except that we can't have an 8 in this box because of 8 in the box. So this is 6 at most here. This is 5, 4, and then 3. So this could be 6, 7, 8, and 9. This can't actually be 8. If this were 8, that would force this to be 9, and that would eliminate all possibilities for that cell there. So this is 7 at most. Can't be 6 or 7. So this is 5, which makes this 5, this 4, that 3, that 2. And 5, 4, 3, 2 adds up to 14. 14 minus 5 is 9. So this is 9 there. That means this can't be 9, it's 8, which makes this 1 and 4 to add up to 8. 4 eliminates 4 in the rest of the column. And the rest is just normal Sudoku. 9 eliminates 9 here, so it's 4. Where is 1 in box 9? Can't be here because of 1 in the column, so 1 is there. That means 1 has to be... Where's 1 in column 5? Can't be here because of 1 in the boxes. Can't be here because of 1 in the row, so 1 has to be there. That means in column 7... 1 can't be here because of 1 in the boxes. 1 can't be here or here because of 1's in the rows. So 1 has to be there. That leaves one of these as a 1 and one of these as a 1 in rows 6 and 9. So what about 2? 2 in row 6 cannot be here because of 2 in the box. Can't be here because of 2 in the column, so it has to be there. Let's not do it this way. This is probably the harder way. Let's go. What's most filled out? This has to be a 6 because of what's left in the box. Now we have column 5, which has 7 filled out. This can't be 6 because of 6 in the row. So this makes this 7, which makes that 6 there. We have 6 in column 6. It has to be 2, 4, and 8. 8 cannot be either of these digits because of 8 in the box, so 8 has to be there. This can't be 2 because of 2 in the row, so this is 4, which makes that 2 there. In the rest of box 8, we have 2 and 6 remaining. 2 can't be here because of 2 in the row, so this is 6, which makes that 2. Remaining digits of column 4, we have 3 and 5, and this can't be 3 because of 3 in the row, so this is 5, which makes that 3. Remaining digits of row 9 are 1 and 7. Remaining digits of row 8 are 2, 3, and 9. This can't be 2 or 3 because of 2, 3 in the column, so that's 9. This eliminates 2 here and 9 here because of 2 in the column, 3 in the 9 in the row, so that's 3, which makes this 2. Remaining digits of row... Well, let's do column 3. We have 4 and 5. Okay, let's do row 8. 4, 5, and 6. This can't be 4, 5 because of 4, 5 in the column. So this must be 6. That makes this a 4, 5 pair here. This is 4, 5 also. We have filled out 6 digits in row 2. So 2, 3, 4 remaining. This can't be 2 or 3 because of 2 or 3 in the box, so this is 4. This can't be 3 because of 3 in the column, so that's 2, which makes this a 3. Row 3, we're missing 7, 8, and 9. 7 can't be either of these because of 7 in the column, so this is 7. 8 can't be either of these because of 8 in the column, so that's 8, which makes this 9. Remaining digits, 4 eliminates 4 here, so it's 5 and 4, which eliminates 4 here, so that's 5. We have 7 digits accounted for in column 7. We are listening for 6 and 9. This can't be 6 because of 6 in the box, so this is 9 and 6. We have 7 digits in column 8. It's 4 and 5. This can't be 5 because of 5 in the row, so this is 4, which makes that 5. That leaves this as a 4, which makes that a 5 there. Remaining digits in row 1 are still 8 and 9. That's not helpful. We have 6 and 7 remaining in row 4. 6 eliminates 6 here, so this is 7, which makes this 6. This must sum up to 24, so I guess we weren't completely done with the region sum line. So that's 6 and 9 is 15, plus 9 is 24. So 9 eliminates 9 here, so it's 8 and 9. 9 eliminates 9 here, so that's 8 and 9. We have a 1, 8 pair here. Actually, 7 eliminates 7 here, so it's 1 and 7. So this can't be 1, it's 8. That leaves that as a 1 there. And that's a solution. I actually would consider this easy. Very easy. I don't see how this would be necessarily difficult. Maybe some of it. I don't know. I just don't feel like the logic behind this is very hard. The execution's not very hard either. So it seems like it would fulfill very easy, fairly not too bad, right? What did I mess up again? Oh, I don't know how I removed an 8 there. Yeah. That was just, I think I messed up. I fat fingered something. Huh. Yeah. I feel like this is a very easy puzzle. Maybe that's just me, though. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.